Hello my champions, how are you all? Welcome to our platform Diksha Karnataka. Today we are starting Matrices part 2. Yes, this is the last of your concept session. After today you'll have more things coming your way in the chapter, don't worry. But by today you'll complete the entire syllabus, the concept part. Got it? Now, before I start the session itself, I have a request to make. I want to tell one story to all of you. Why this story? Because I am very sure that each and every one of you will be able to relate to this story. Okay, so this let me start. So this thing happened with me a couple of years back. There was a student in my class who used to struggle a lot in mathematics. When I say struggle, I mean really struggle. Getting 20% marks is very sometimes it is very bad, sometimes it is very disheartening, all of that. Even for us as well as a teacher, sometimes it gets very frustrating also, okay, that you are teaching something and student is not able to reciprocate to that. We feel as a teacher that he is not putting the efforts. Okay, even I had the same assumption that he's not putting the effort. Now what happened was, one very fine day, this student comes to me in the staff room and he says, sir, you said this thing to me that I am not doing any work. Okay, and I told him in the class, and he just came to me, he showed his class notes. Okay, when I saw that, I was really surprised. So this, let's say, if you take an example of an NCERT exercise, and that exercise has 20 questions in it, he was doing every single question. He has attempted every single question, and I was surprised, still those 20% marks. The problem was, he was not able to complete those sums. Do you feel it when you're solving a question, okay? After some time, what happens is, you get stuck at a point, whether maybe because of any formulas, because of any trick in that particular question, or maybe in the diagram part of geometry, but you get stuck, right? So because of that, he used to leave that question and then move on to the next one. And this was a pattern in all of his problems that he was solving. He was putting efforts, okay? That's the best part. That's the reason that I was very happy that he's somebody who's putting efforts. There's not even 1% lack in the effort. But yes, he was at a point where he needs help. And I came up with one idea. We both, talked about it. And then we decided, apart from the homeworks, physics, chemistry, math, whatever it is going on, apart from the homework, he will have to do one task for me. And the task is very simple, 7 questions per day. 7 questions, remember this statement, 7 questions per day. Now in that also we had a bifurcation. 7 questions means the first 2 will be easy questions. First 2 will be easy problems. Next 4 means question 1, question 2 is easy. Question 3 to question 6 will be the questions where he gets stuck in. Means maybe formula challenging or some level of challenge will be there in the next 4 questions, and the last one will be a difficult question that he cannot solve only. Means that, right? As a student, you look at a question, you say skip it. You can't solve that question. So that was 1. First 2 easy, next 4 challenging, and the last one, the difficult one that he cannot solve. 7 questions he has to solve every day. Now there was one condition that he has to complete all these 7 questions. Complete means what? Sir, if he doesn't know, how would he complete it? Because he can take help from me, take help from his friends, from his parents, or from any tool available online. But goal was to complete all the questions and clear the doubts. Okay, I told this to him. I followed him for a few days, and then I just continued with my classes and I forgot about this. After 2.5 months, something like this, there was a test which happened in our school. When that happened, that guy scored 73 marks out of 100. 73 marks out of 100. Now think about it, from 20 marks to 73 marks. The journey of 53 marks in 2.5 months, this happened. He came to me, he told me that he continued with the same process. He continued with the same thing and he got this result and is doing very good now. My point from here, for all of you will be, one thing is consistency, that you all know. You all must be fed up with this word. So everybody comes and say about the consistency. We don't get it. How to tackle the word consistency. I'm going to give you the secret for it today. So what happens, yes, it's very important to be persevere, it's very important to be consistent in your work, that's there, without a doubt. But most important part is accepting that what you're doing is right. So what happens when you are learning something, when you're solving a question and you get challenged, what you do is you feel, okay, it's not working out, let's leave it. Actually, when you solve a question, you get stuck in it, it means it's working out. You're on the right path. I'll give you an example. Might be confused? I'll give you an example. Let's say you're learning driving, right? If you know how to drive, is it difficult for you? If you know how to drive, is it difficult for you? Let's say you can ask your parents, okay? Your brother, elder sister. If they know how to drive, is it difficult for them? They'll say no. But when they were learning to drive, was it difficult? Yes. So when you are learning a concept, when you are learning a problem, it will be challenging, it has to be challenging. That's why you are learning something. If you already know it, then you will not have challenge, right? It means you're not learning it anymore. So understand this very carefully. Any new concept, any new problem will be challenging, and if it is challenging means the process is right on track. You're on the right path. If you see through it, you will be, getting an output from it. Okay, so of course being consistent is there, but understand the process that if it is challenging, it means it's working. It means you're learning. That's how learning works. Okay, so being challenged not a problem. Just get your doubts cleared, get it done, complete the process and see it through. Let's say for the next 1 year that you have before the examination, be consistent and understand whenever you get struggle, it's okay. What you have to do, if you're struggling in a question, just complete it. Use any tool which is possible, but complete the problem. If you do that and if you be consistent in the process, you will be getting a very good output of this entire journey. This was a story that I had to tell to all of you. Okay, now I have taken some time of yours, I understand that, but if you are here with me till now, don't worry, we'll have a fun solving all the questions. So today I've gonna taken a total of 11 questions. Okay, today I've taken 11 questions, but there's more of concept today. Concepts are properties, matrix multiplication, transpose, and after that we'll also see skew, symmetric and symmetric part. Then you have CET PYQs and JEE mains PYQs coming in the session number 3 and session number 4. That is clear? Okay. Now you're here because your seniors from the previous batch scored outstanding result. Just studying from YouTube, from this platform, from this very content, from us, from Aishwarya ma'am, from Jasmine ma'am, from Swamik sir, from me, your Ankit sir, they studied and they got outstanding result. We can't take even all the names. This is just for CET. They got, a lot of students got 100 marks in physics, chemistry, maths and like that, biology. Okay, so if you are here, trust us and follow the content properly, be consistent in the process. I'm telling you, you will be next on the screen with your name, with your result in the KCET 2026 results. Okay, that's a promise. You have to make a promise that you're going to be consistent and trust us, thoroughly follow our content, okay, without missing anything. Chapter Insight is an easy chapter, right? It's not a difficult one. Calculate a little bit, okay. If you're aware of the calculation properly, you'll get very good marks in the questions coming from matrices. Again, it's a high weightage chapter. It's a very high weightage chapter, okay. In all the question chapters, you can see even the CET 4 to 5 questions can come from here. Minimum 3 to 4 questions can come from here. 3 to 4 questions can be expected from this chapter itself. Okay, if you see the previous year also, you'll see when I start solving the KCET questions, right, I'll show you. Okay, less theory, more solving, that's what is there in this chapter. Next you go, and it also helps in other topics, also helps in physics also, and we're going to cover some of the topics over here. What are those? Inverse, some definitions will be there. Mostly will come in the case of where determinants. Okay, inverse is dealt more in determinant. Okay, then types of matrices, we have already done that, and we'll see transpose today in the session. Okay, I know you have been waiting a long time for this. We'll start quickly, don't worry. So if you see the session outline, what we have, matrix multiplication we start with, we go to the properties next, moving to question number 1, then we go to positive integrals, powers. There are a lot of questions coming in this way. Looks very simple, but there are a lot of questions coming from this topic. Okay, so then we solve question number 2 to question number 4. Transpose of a matrix, we go ahead and learn that, and next we have definitions of skew, symmetric and symmetric matrix, and next is the practice from 5 to 11. This is clear? Okay, I'll give you a homework also. There will be a homework also. This is session outline. Now let's start the session itself. Now we have multiplication of matrices. When can you multiply? I'm not talking about a scalar multiplication. I'm talking about matrix to matrix multiplication. What is it called? Matrix to matrix multiplication. Okay, it's not difficult, easy only, but you have to be careful around it. So first thing is, understand that you can define a product of two matrices only when, I'll repeat, you can define the product of two matrices only when number of columns in the first matrix. Why I say first matrix? Check here, matrix over here, let's call it to be first matrix. Second will be here, B, AB, not BA, AB, they're different actually. AB and BA are different over here. So first you write AB, AB, then A comes first, B comes later. So the number of columns in the first matrix, let's call it to be 2 cross 3. 2 cross 3 will be equal to, this is number of columns, right? Should be equal to number of rows in the second matrix. So this would be equal. Please understand this carefully. Number of columns in the first matrix should be equal to number of rows in the second matrix. If that is the case, then you can say this matrix multiplication AB is defined. That's how you do it. Great. Now BA, what about BA? That will happen only when if you have again same condition followed, 3 cross 3, and the resulting matrix AB. So AB will also be a matrix, right? Let's call it to be matrix X. Correct? Even AB is a matrix, right? We'll call it to be matrix X, let's say. So the matrix X will have an order of 2 cross 2. Okay, see here, the number of rows over here and number of column over here will be the number of row and column for your resulting matrix, which is nothing but the product of these two, matrix. So two things I've told you over here. To multiply, to say that the multiplication is defined, we need the number of columns over here, number of rows here equal. Second thing is that you need the order of the output will be these two combinations, number of rows from the first one and number of columns from the second one. You always multiply from, this is the first thing, clear. Second thing is the multiplication is done always from row to column. So if I have here, no, let's say 2 cross 3, right? Yeah. So we have this. So you always multiply row to column. Okay, you're going to multiply the first row, let's call it to be first row to column 1. You'll multiply first row to column 1, and that will give you one element of the resulting matrix. Don't worry, I'll show you. Okay, square matrix A is said to be idempotent matrix if it is coming out like this, means A square equals to A will be called as idempotent matrix. Okay, it's important. Sometimes question can be asked in this also in your KCET. Great. If you move on now, I'll show you the multiplication. Check this out. So AB, we'll talk about only the definition of the matrix multiplication. Check here. So what is the matrix A order? It's 1 row, 3 columns. Please check, 1 row and 3 columns. Okay. Whereas for the matrix B, what do you have? You have 3 rows and 1 column. 3 rows and 1 column. Okay. Now if you multiply, what is the result? So we'll see. First, can we multiply or not? Yes, we can, because we have number of rows and number of columns equal. Number of columns to number of rows over here equal. The resulting matrix, let's call it matrix X. What's the order of that? 1 cross 1. 1 cross 1. This is clear, right? That's what we learned right now so far. Okay. 1 cross 1. That's your order. Means basically one element. How do you solve it? Please check. So what you do in this case now? You multiply this matrix here, 1, 3 and minus 4 to this 5 minus 4 and minus 2. And how do you multiply it? I just said this row to this column. Always multiplication is from where to where? From row to column. So you multiply like this, the like elements. 1 to 5, right? 1 to 5 is how much? 5. 3 to minus 4, how much is that? Minus 12. So put a plus sign here and write minus 12. Again, the last one, minus 4 to minus 2, plus 1 comes here with plus 8. Is that clear? Minus 4 to minus 2 becomes plus 8. Now you add all of this, you have the result as 8 plus 5 is 13, minus 12 is how much? 1. And that's your resulting matrix. Okay, that's how you multiply. Row to column. This is your row matrix and this is your column matrix C1. Okay, row 1, there is only one row, and this is column 1, this is C1. So row to column matrix, if you're multiplying, you'll have the result as a singleton matrix. Basically, you'll have only one element over here. Okay. Here BA is also defined because number of columns in BN, this is equal. How, sir? Please check. So BA we are talking about, right? What is BA? BA is 3 to 1. And A is what? A is 1 to 3. You check here, 1 and 1 is same. It means BA, the output, if I take this to be matrix Y, it comes out as 3 cross 3. If you multiply B to A, no, you'll get total of 9 elements. I'll show you. Okay, B to A. Check this out. I have to write B first. In that case, I have to write B first. What is B, sir, here? 5 minus 4 and minus 2. That's B here. And A will be over here 1, 3 and minus 4. I'm talking about the result, right? The matrix Y. Let's see. I'm teaching you the entire multiplication over here only. Again, what I said, row to column. Result is row to column. Multiply row, first row. This one. 5 into 1. 5 into 1 is how much, sir? 5 into 1 is 5. 5 into 1 is 5. Again, same row to say the complete thing. Check this out. First row to the entire column, right? First row to the entire column. What is the entire column? 5 into 1. Correct or not? Not clear? Have a look. First row to the first column. Correct. 5 into 1 is 5. That's all. Done. Next one. First row to second column. 5 into 3. 15. 5 into minus 4. How much is that? Minus 20. This is your first column now. Again, this is not adding them. This is the individual elements of the first row of the resulting matrix. 5 into first row to first column is 5. First row to second column is 15. First row to third column. How do we do it? Row to column multiplication. Please pay attention over here. Might be a little boring, but this is how it is done. Very important to learn it. Okay, the basics. Next, we're going to start next with row number 2 and the rest of the columns. Minus 4 into 1 is minus 4. Minus 4 into 3 is minus 12. Plus 16. Okay, and minus 2 into 1 is minus 2. Minus 2 into 3 is minus 6. And plus 8. That's your resulting matrix. When you multiply B to A. B to A result is this, and A to B result is 1. Please check. Okay. Now, few of you might know how to multiply, but still, if even one student is not able to understand that, my job is to explain it to them also. So it is clearly explained how do you multiply matrices in both the cases. Whether you are talking about AB, this is AB, and this is for BA. This is for BA. Clear? Very clear. Simple one. Let's move on now. So this is multiplication explained to you how you multiply, how to take the order. Now we'll go to the properties of multiplication. We go to the properties of multiplication. Understand this carefully. The matrix multiplication is not commutative. Is not commutative. So excuse me. So what I mean by this is when you multiply AB to BA, okay, AB and BA you multiply, they might not be always equal. Actually what happens, they are equal only when A is the inverse of B. We'll learn that later, don't worry. But whenever you have A and B are inverse of each other, then only we can say AB and B are equal. So always, not always two matrices will be what? Inverse of each other, right? So of course, not always commutative. Not always commutative. They have written the word here. Please check. General. Generally, not always commutative. It can happen, but only in the case of inverse. Got it right? No problem here. Okay. Now second property, matrix multiplication is associative. This is true. Whether you multiply AB first, then to C, or BC first and then to A, result will be same. So matrix multiplication is associative. That is not a problem over here. Now, if you are having this case, matrix multiplication is also distributive in nature. Means you can add first B plus C, then multiply A to it, or simply multiply A to B and A to C, then add also the same result. So you can multiply first, then add, or add first, then multiply is same. It's basically distributive property over addition is true. Okay, here also. Also true for subtraction as well. Okay, so over addition or subtraction, this distributive property is validated. Clear, simple properties, not big ones. Now, I want to say thank you to all of you. When I read these comments, I feel really happy. Okay, for example, especially this comment. Every question understood, sir. This was a comment, I think, in one of the KCET PYQ videos. Prajwal King DC. Prajwal has been following all the content very regularly. Prajwal wrote this. Every question understood, sir. It was very happy moment for me because I know as a teacher this is what the reward we get, right? Your comments. So please leave any of your feedback in the comment section. I really appreciate it. Okay, and Gowda has said that sir, I think I am really blessed to have your channel for free. Of course, thank you. I can secure best rank in KCET. Thank you so much. I'll promise you that I'll work hard to secure a best rank in KCET. It makes me speechless. Not only me, all of us, all of the teachers over here on our channel makes it speechless. For such lovely comments and so much appreciation for our work. Okay, please keep your love. Please keep giving your love to us. It makes our day when we come in the morning to office and see your comments. Unfortunately, sometimes you guys keep your comments in the late night and we are missing that. So after a few hours, we see your comments. But when we see the comments, we really feel very happy. and it makes our day in the morning itself. So anything you want to say to us, whether negative or positive, you're going to leave that in the comment section. It's very, very, appreciated. I love it when I see those comments of yours. Okay. Now some more properties. Property number 4, the product of two matrices can be null matrix while neither of them are null matrix. Means matrix A is not a null matrix and matrix B is also not a null matrix, but even AB matrix can also be null matrix. My point is, even though A and B are individually not null matrix, but result can be a null matrix. But that's okay. How come so? Because when you multiply the matrices, no, A and B, what happens is you multiply and then add. For example, over here, see, you are adding, no? So it was minus 12 and 8 plus 5 is 13. But if you had a situation where it was 8 plus 4, think about it. 8 plus 4, how much is that? 12. If it was 4, if it was not 5 but a 4, then 12 minus 12 will become 0. So even though the matrix is not 0, the result will come out as 0. Getting my point or not? So even though A and B is not equal to 0, but result AB can be equal to 0. I hope this is clear. Okay. Property 5, if A is given a square matrix and I is an identity matrix of the same order, okay, then what happens is AI or IA is same as A. This is very understood, right? Multiply, basically, let's say order of matrix is 2 cross 2, square matrix, right? See here, and identity matrix also order is 2. If you multiply AI, right, you get the answer as A only. Multiply AI or IA, answer is A. Sir, very silly one? Not silly actually. You have taken a question today. I'll show you how it works. Okay? A lot of EYQs have been used this property to solve the questions. So it's very, very, very relevant to you. Property 6, if A is given square matrix and 0 is a null matrix, of course 0 into A or A into 0 will be 0. 0 to multiply anything will be 0 only, right? That's there. Next we have first question on multiplication. So we'll see. It might take some time to solve it, but we'll solve it. So they are saying that verify basically what is this, sir? This is one of the properties. This is called as distributive property, right? This is called as distributive property. Okay. So they are saying that you multiply A to sum of B and C, and then so AB plus AC is same as that. Okay. So I've already taken AB and AC just to make some time doing calculation. I've already taken AB and AC. Okay. If you want, I can show you how do you multiply AB. So A is here, B is here. 2 into 0 is 0. 1 into 2 is 2. 0 into 1 is 0. How did I do that, sir? By row to column multiplication. Row to column. First row, first row. 2 into 0, 0. 1 into 2, 2. 0 into 1, 0. Answer is 2. So you do row to column multiplication, you'll get the result. So for AB and for AC I have done. If you want, you can pause the video, do your own calculation and check the result. Okay. So AB and AC I've got. I'm going to solve for left hand side. I want to solve for LHS. What is LHS? A times of B plus C. Let's solve for B plus C first. What is B plus C, dear? B plus C is over here. 0 plus minus 1 is minus 1. 2 plus 0 is 2. 3 plus 2 is 5. 2 plus 1 is 3. 0 plus 3 is 3. And we have 2 over here. 3 and minus 2 and 5. 3 and minus 2 and 5. This is B plus C. Multiply A to this. B plus C. Multiply A to this. Where is A, sir? Over here. Okay. How do you do it? Row to column, right? Row to column. So right here, 2, 1, 0, we're going to go. I'll write it over here for you. So we'll write here 2, 1, 0 and minus 3, 0 and 5 with the same matrix. Minus 1, 2, 5 and 3, 3, 2 with we have 3 minus 2 and 5. How do you multiply it? Can you multiply it or not? Write the order to cross check. Order is what? Over here 2 cross 3. Here it is 3 cross 3. 2 cross 3 and 3 cross 3. Multiply and get the result. Answer will be 2 cross 3 only, right? Answer will be 2 cross 3 only. Correct, na? This is common and this will be 2 and 3. The resulting matrix order. Okay. Multiply 2 into minus 1 is minus 2. 1 into 3 is 3 and 0 into 3 is gone. What is I'm getting? Minus 2 and plus 3. Remember, I'm not going to write everything over here. 2 into minus 1 is minus 2. 1 into 3 is plus 3. Add that. You get 1. You get 1 over here. Okay. So first row, 0 into 3 is 0. So I have not taken that out. Now first row, second column. For the second element. Second element, first row, second column. 2 into 2, 4. 1 into 3, 3, which is 7, and 0 into minus 2, 0. So we get here 7. Please check. 2 into 2 is 4, and 1 into 3 is 3. Add them, we get 7. Next one. First row, last column. 2 into 5, 10. 1 into 2, 2. So means 10 plus 2 is 12. This is gone. Right? 2 into 5 is 10. 1 into 2 is 2, 12. And 0 into 5 is 0. That's cancelled. Okay. Minus 3. Now we're going to start with second row, all the columns. Minus 3 into minus 1 plus 3. 0 into 3 is gone. 5 into 3 is 15. So 18 over here. How come, sir? Minus 3 into minus 1 is plus 3. Okay. And 5 into 3 is 15. Plus 3 becomes 18. Minus 3 into 2 is minus 6. Okay. 0 into 3 is 0. 5 into minus 2 is minus 10. So minus 6 and minus 10 is minus 16, right? We'll cross check once again. Minus 3 into minus 2 is minus 6. 5 into minus 2 is minus 10, becomes minus 16. Okay. And the last one here, minus 3 into 5 becomes minus 15. 0 is gone, and we'll have 25. So we get what? Minus 15 plus 25 will be 15 only, 10 only, right? Please check. Minus 15 and plus 25 is 10. Okay. Let's move on now. Okay. Sorry, I forgot. So we have to add this also, right? We can't move on. So we have to add this also. So AB plus AC will do. Let's check. AB plus AC will do. What we get if we add these two? We get 2 plus minus 1 is 1. 4 plus 3 is 7. 5 plus 7 is 12. 18, minus 16, and 10. Are these two same? Please check. Yeah, they are. It means they're equal. Proven, so this is proved. Got it? So there's no multiplication problem now in matrices. How to multiply? You understood now. Let's move on. Okay. Now positive integral powers of square matrix. Looks silly but very important topic. Lot of questions have been asked from this topic. What do we do? Simply understand this. You will take simply powers of matrices the way you take in the index of variables. So basically this word will be enough. You have learned the chapter no indices. Sorry, indices you have learned, right? 4 variables you have learned in algebra. Okay. Same property you're going to use. Okay. Sometimes you also call this to be exponent. Remember, exponents. Same property. You're going to use exponents. Rules, basically. If you use it, except for the negative ones, except for the minus 1. Not for this. Not for this. Because, read the statement. Positive. The word is positive. Not 0, not 2. Minus 1. Okay. You're not going to go for the negative ones. So, rules will be applied, whatever you have learned. But use what? The rules of for positive integral powers only. Clear? So no need to remember all these things, how the property is working out. That is okay. Just remember you have learned the indices, right? You have learned the exponents. Only remember the properties for the positive side of the powers. Means 2, 4, 1, 2 like that. Not less than 1. Not 0, not minus. Works? Let's solve some questions. Okay. Now second question, they are asking what? The order of the single matrix obtained from this. Basically they are asking the result. Let's say the result matrix is X. That's the result matrix. Okay. So think about it. There is a multiplication over here. There is a multiplication over here. So first of all, this difference will give me some output. Okay. Let's call this to be matrix A. Okay. And this difference will be, let's say, matrix B. Okay. So matrix A times of matrix B. Correct. Difference will be matrix B. So what is the order of that? See, 2 rows, 3 column, 2 row, 3 column. 2 cross 3. Yes or no? Both of these has 2 row, 3 column. Then only we can subtract, right? Remember, for addition and subtraction, we should have the matrix to be conformable. Means same order. So 2, 3, 2, 3 both. We get the order of B to be 2, 3. What about this two? We have 3, 2. 1 row, 2 row, 3 row, and 2 column. So we have 3, 2 over here. If you operate, you will get X as 3 cross 3. If you do the multiplication, you will have X as 3 cross 3. Option will be D. Option will be D. I hope this is clear. Had fun? Okay, question number 2 is done. Okay, sir. Now question number 3. Now over here they are saying that find the value of K if the equation is given to you in the matrix form as A square minus K minus 5i. Okay. First step is to find A square. How do you find A square? Exponents, A into A. Right, A into A. A is 1, 3, 3, 4. Here also 1, 3, 3, 4. Right? Multiply. Row to column 1 into 1 is 1. 3 into 3 is 9. Right? 1 into 1 is 1. 3 into 3 is 9. Again 1 into 3 is 3 and 3 into 4 is 12. Right? 3 into 4 is 12. Okay? Last one. Second column. Sorry, second row. 3 into 1 is 3 and 4 into 3 is 12 again. And 3 into 3 is 9 and 4 into 4 is, what is it? 16. Result you check. My square of A is coming out as 10, 15, 15 and 25. Correct? 10, 15, 15 and 25. Okay. Now what are they saying? Find K. Find K. So what is this? Have a look. We have 10, 15, 15, 25 minus K into A. What is K into A? 1, 3, 3, 4 minus 5 into I means 1, 1, 0, 0. Right? Equals to 0. Please check. So I want to find the K value. I'll keep this whole thing on the side of the 0. So I get over here. I get here 10, 15, 15, 25. I know you can solve it faster, but my job is to make sure that everything is complete. So 5 into 1 is 5, 0, 0, 5. You don't need to write this step to get the answer, okay? No need to write this step, these many steps to get the answer. You can get directly from here. Think about it. So what is missing over here? Please check. 10 is here. It should be 5 only, no? Then you can get, this whole thing is 5. Then you can get, right, 5 minus 5 will become minus 10. Here, minus 5 here, minus 5 here becomes minus 10. You already have 10 over here. Then only 10 minus 10 will become 0. Hence, answer is K equal to 5. Option A is correct. Got it? No? K into 1. How much is that? Minus K. Think about it. 10 minus K minus 5 should be 0. It means K should be 5. Correct or not? Correct or not? Yes. Otherwise, you can do what? Compare on this side. Bring over here. You'll have K and 3K, 3K and 4K. Subtract over here and then compare. Your choice. You can use this method, one more step, or you can write the answer from directly over here. Getting it? Just one thing is to do. Finding A square is important. You have to do that. Okay? Without that, you can't solve it. So A square is done. Question number 3, option A is correct. Clear? Question number 3, option A is correct. Okay. 1 second. Let's move on now, sir. Let's move on. Few more concepts now. Okay. Before that, I have a question to solve. Let's solve it. We have given, we've been given as matrix A alpha 0 1 1 and matrix B is 1 0 5 1. Find the value of alpha 4 which A square equal to B. A square equals to B. Let's multiply A square. First find A square first. We have A into A as A square. Same thing we're going to do. We have over here alpha 0 1 1 alpha 0 1 1. Okay. Alpha 0 1 1 multiply it. We get first row to first column, we get alpha square and this will be 0, so gone. Okay. And again we do this is 0, so this is 0 simply. Okay. Remember na, alpha into 0 is 0, 0 into 1 is 0, so that's 0 completely. Second row to this first column we get alpha plus 1, the first term, and this will become 1 into 0 is 0, 1 into 1 is 1, so this is the term. This is equal to B. What is B given as? This B is given as 1 0 5 1. How we get this? Because we have given alpha square equals to B. Alright, compare over here. You're getting from this alpha square equals to 1. It means alpha equals to plus minus 1. Plus minus 1. Okay. Visible? No. I'll write better. Yeah. Alpha equals to plus minus 1. Okay. And from this one, compare these two, you get alpha square, sorry, alpha plus 1, excuse me, alpha plus 1 as 5. Alpha plus 1 as 5, it means alpha is 4. Check this out, you have options as plus 1, minus 1, so basically alpha should be what? You can't have any one value, can you? Okay, so basically you can say that answer is no real values. How come, sir? Because you have 3 options, none of them are common, right? If they were a common value, you can say we are getting 2 different values. Can you put any one value of alpha which will give me this condition true? If you put 1, not satisfied. If you put minus 1, not satisfied. If you put 4, so there is no one value of alpha which will make this condition satisfied. Because from the first equation we are getting a different value, from second we are getting a different value. You put here alpha as 1, 1 plus 1 is 2, is it equal? No. Alpha as 4, 4 square is 16, is it equal? No. So there is no single value of alpha which will give me the equations are true. It means that there are no real values for given particular question. Okay, alpha is not defined only for this given condition. Next we have transpose of a matrix. Transpose means what? Basically write a matrix. Let's do that. 1, 2, 3, 5, 7. Let's write it as rest of all of them 0. 1, 2, 3, 5, 7. So basically when I say transpose, let's call this matrix A. When I write matrix A transpose, now what happens is the columns becomes rows and rows becomes columns. So this is the row, right? It comes over here. 1, 2 and 3, and this goes over here. 5, 7, and this remains again 0, 0, 0 only, no? All 0. Check this out. The row was 2, 0, 0, it became column 2, 0, 0. The row was 3, 0, 0, it became column 3, 0, 0. So the row becomes column. In transpose, the row and column interchange each other. The row and column interchange each other. Okay? Please check. And not only that, in this case we had a square matrix, right? 3 cross 3. This is 3 cross 3. But if we have a case of a rectangular matrix, then what will happen? Order will change. Here the order is 2 cross 3. Here the order will become 3 cross 2. Because the row and column will interchange, right? What is it? 2 rows becomes 2 columns. Please check. 1, 2, 3 vertical, 2, 0, 5 vertical. And the 3 columns becomes 3 rows. 1, 2, 1, 2 here was column, here becomes here row. We have 2, 0, column number 2 becomes row number 2. We have 3, 5, column number 3 becomes row number 3. So the column and rows becomes, by interchanging each other. Okay. So order also changes. Remember, but in the case of only rectangular matrix, on the case of only rectangular matrices, the order will change, otherwise it will remain as it is. Okay. Got it? If you see carefully, here the element was Aij, here the element is Aji. Means if I had the element A11, A12, okay, so A12 will come over here and becomes the element A21. Correct, now? The elements come over here. Basically, if you see the flow of this transpose, okay, I'll show you with example later, but if you see the flow, the movement will be like this. So if I write here A11, A12, A21, A22, okay, then for the transpose, what I'm going to do, I'll write here A11 and this will move on this side and this will move up. Okay, this is my matrix A, right? Then matrix B, which is nothing but transpose of matrix A, will become A21 over here and A12 over here, and this remains as it is. So let's write B equals to what? B equals to A transpose. B equals to A transpose. The ways to write this is sometimes A dash or AT also. Sometimes you write it as A dash or AT also. Got it? Means the same thing. So if B is nothing but A transpose, what happens is the diagonal remains as it is and the other element swap its places. Got it? Simple enough? Okay. Because on this property only the concept of skew symmetric matrix and symmetric matrix come, and from there you have a lot of questions. So today in the session I'm not going to teach you the questions of skew symmetric symmetric. I'll take that in the KCET PYQs. But I'm going to teach you the concepts over here. But the questions I'll take in the KCET PYQs. Is that clear? Okay. So properties of transpose of a matrix. Let A and B be any suitable matrices. Then A plus B transpose is simply written by open them with transpose of each other. Okay. So A dash plus B dash. A dash plus B dash. But not in the case of multiplication. We'll see that later. If you have transpose of A, again transpose one more time, comes back to A itself. If you have transpose of A, you transpose it again, it will go back to transpose. Okay, got it? So because matrix will once change to row column, again column to row. Got it? Transpose to transpose, you'll have the original matrix back with you. Property 3, again if you are having a minus sign over here, it comes back as it is. A dash minus B dash. Okay. If you have a constant K over here multiplied, you can keep the constant outside. K is outside. Same goes with the minus sign also, can be kept outside. But in the case of multiplication, things change. In the case of multiplication, things change. What happens in this case? If you have AB and you want transpose of this, A and B are of course multiplied, it's a 2 matrix which is multiplied. You want transpose of the multiplication, the result changes, it becomes B dash A dash. So first you get B dash and then you multiply that to A dash. Have a look. So over here, yeah, it's written A dash, A B dash becomes B dash A dash. Same if you have 3 matrices. So if you have A B C, first comes C dash, then comes B dash, then comes A dash. Reverse order. Reverse order. Okay. C dash, B dash, and then A dash. Okay. Reversal law of transposes. Reversal law of transposes. Important. Highly important. This one and the first one. Basically, the sum 1 matrix is used a lot. You'll see that in the questions. Okay. Clear? Simple enough. Let's move on. Okay. So now, the last concept, which is symmetric and skew symmetric part. Okay. So in this particular thing, what happens is we use the concept of transpose. So how do you do it? Let's say I'm saying that matrix A is symmetric matrix. Is a symmetric matrix. So first I'll show you how does it look like. How does any symmetric matrix looks like? I'll talk about only 3 cross 3 order, okay? Don't worry. Okay, I'll talk about only 3 cross 3 order. Achha, one more thing, this is applied only to square matrices. Applied to square matrices only, okay? Let's write here 1, 7, 9, minus 2, 5, 5, 8, 8. I hope you can see the order now, the pattern over here. So basically across the diagonal, across this diagonal, if you have these elements same, these two, and these two, if you have these same, it's called as symmetric matrix. I'll erase that marking, don't worry, but that's how it works. Okay, that's how it works. Now, this doesn't have to be explained with the help of diagram always. We have a formula for that. That formula is whenever you have Aij equals to Aji. Aij equals to Aji. Okay, how come, sir? What's this element position? It is A12. This element position A21. This element position is A13 and this element position is A31. Over here A23 and this is nothing but A32. Got it? So whenever you have Aij and Aji equal, you call that to be symmetric matrix. You call it to be symmetric matrix. Okay, that's one thing. Secondly, very important, if you are taking transpose of a symmetric matrix, it's already told to you, if it is told to you that transpose is, like, if it is known that A is symmetric, it is known to us. It is known to us. It is given basically, it is given that A is a symmetric matrix. If that is given, then A transpose is nothing but the matrix A itself. Okay, whenever you can get, if it's given that A is symmetric matrix, it means that A transpose is going to be the matrix A itself. Okay, now if you are moving on to skew symmetric side, skew symmetric matrix, okay, second category, then what happens is things change. Over here you have Aij equals to minus of Aji, minus of Aji. That's the definition. Aij equals to minus of Aji. Basically, write a matrix B over here, okay? And if I write the same thing, if I'm writing here 1, 7, and 9, then how will other elements look like? If it is minus 2 dear, it will look like 2, okay? If it is 5, it will become minus 5. If it is 8, it will become minus 8. So the elements that you see, okay, in these positions will be what? Will be basically opposite in sign. Okay, check here. So your A12 is nothing but minus 2, but A21 is what? Simply 2. So basically A12 is minus of A21. Won't you agree? And same can be applied for other elements also. So always will be negative or opposite in the sign, like this. Okay, I have made a mistake. Unfortunate one. Yeah. in the case of dear skew symmetric, this will always be 0. Diagonal no will always be 0 actually. I got in the flow, but it will always be 0. That's a property. In the case of skew symmetric matrix, diagonal is always 0. One property you learnt over here, second property will be over here. Please check. Diagonal elements are 0. Diagonal elements is 0. I'm not saying that when diagonal elements are 0, always it will be skew symmetric, but I'm saying if it is skew symmetric, it will be always 0. Ulta is true. If the diagonal element if it is skew symmetric matrix given to you, then diagonal has to be 0 all the time. How it is there, I'll show you. Let's say from this principle only we are using A11 equals to A11 we're going to write minus A11. How come, sir? Aij, right? Aij equals to minus Aji. When I is equal to 1 and j is equal to 1, that's how you write it. A11 equal to minus A11, the property. Move on this side, what do you get? A11 plus A11 equal to 0. From what you get from here? Twice of A11 equal to 0. It means A11 has to be 0. And similarly, A22 and A33 also is 0. Got it? A22 and A33 is also 0. This is clear. Okay. Now, before I move on to the question, I want to give you a remark which is very important. The remark is any matrix, any square matrix A can be written in the form of skew symmetric and symmetric matrix. And how do you write that? You can write this matrix A as A plus A dash by 2 plus A minus A dash by 2. A minus A dash by 2, where this part over here is called as symmetric matrix part and this part is called as skew symmetric matrix part. This A minus A dash represents skew symmetric part and this A plus A dash by 2 represents symmetric part. So if somebody is asking you to write a given matrix, square matrix in the form of symmetric and skew symmetric, you're going to write in this form. Just find the transpose of that matrix given to you and add them, divide by 2, you get symmetric part. Add them, subtract them and divide by 2, you get skew symmetric part. Is that clear? Can you solve the questions now? Is it done? Clear? Okay. Questions now. Question number 5. So this is your homework question. Okay. I'm going to solve the first one, but you are supposed to verify the other one. This is your homework. Simple one only. Homework. What is the comment then? Comment will be, okay, verified, sir. And I'm going to trust you that you have actually verified it. I have to trust you that on that, okay? So you have to add it, then take the transpose, and then first, secondly, for the RHS side, transpose first, then you're going to add it later. I'll show you the first one. So A transpose to transpose. What is A transpose going to be looking like? Please check. We have A over here, 5 and 7 remains as it is. Transpose means minus 1 comes over here and 6 goes over there. I'm looking for transpose of the transpose. One more time. What happens over here? 5, 7 as it is. 6 comes over here and minus goes over, 1 over goes over here. This comes and this goes up. Okay. So is it same as this? Yes, of course. So this is simply A. So A transpose to transpose is nothing but simply matrix A. Similarly, verify the 2 and third one, second and third one. You will do that. You will do that. It's a homework. Please do it. And comment in the comment section that verified, sir. Okay. Question number 5, verified. Simple one, right? Okay. Next one is this question. You might want to do this. You might want to find A transpose and then write like this. Cos x remains same, sir. This minus sin x comes over here, sir. The sin x goes over here, sir, and then multiply this to A, sir, basically like this. A over here and this over here and get the result. Or simply, wherever you have this in the square matrix, answer is always I. Whenever you have this property in the square matrix, answer is always I. N actually. What is N? N represents the order of matrix. Order of matrix A. So whenever you have A into A transpose, check here. A into A transpose. What is the answer? Answer is simply Answer is simply I2. Option B is correct. If you want, you can do it like this and verify, your choice, okay? But if you remember the property states that if you have to multiply two matrices which is basically transpose of each other, answer is always identity matrix of the same order, okay? Question number 6 is done. Question number 7 now. If A is given to you and you're asking to find what? A16. First thing is to what? In all these kind of questions, whether they say A1000, A2000, whatever it is they're saying, first step is to find A square. From there you're going to get a property. 0, 0, x, 0, 0, 0, x, 0. Check this out. This you multiply to this, answer is 0. To this, answer is 0. Correct, no? This is both 0. Anything you multiply to that will be 0 only. Now, check for the second column. So, second row. X into 0 is 0. 0 into x is again 0. X into 0 is 0 and 0 into 0 is again 0. So, square of A is coming out as 0 matrix of order 2. It's not oxygen. This is not oxygen, okay? This is 0 matrix of order 2, not a chemistry class, maths class. 0 matrix of order 2, it means you take any power to this, it will become 0 only, right? Answer is option D. Let's move on to question number 8 now. Let A equals to cos square theta, sin theta, cos theta. Now over here is very important to do the multiplication right. But don't go for, lot of multiplication. Only writing the first term will give you answer. I'll show you. I'm looking for AB, right? So AB I'm going to do. How do you multiply anything? Row to column. First row over here, please check. Cos square, sin theta, cos theta, and over here, column, right? Row to column. Okay. So what I get? I get here cos square to cos phi. I'm writing only first term. Cos square theta to cos square phi. Multiplied. Clear? Okay. Next term is sin theta cos theta to this term. Cos phi, sin phi. Okay. Multiply sin theta cos theta. So we'll get first plus sign over here. Sin theta cos theta. Okay. And here cos phi, sin phi. Understand this very carefully. This is your first term, not the two terms. This itself is one term over here. Correct, na? First row to first column gives you one term. That is one term. Of course, you'll have term over here also, and over here also. You'll have total of 4 terms, right? I'm not doing that. No, not required, because if you check the numbers, no, you'll always end up with the same thing. I'll show you. Now check this out. We have cos theta cos phi common. Cos theta cos phi common. Let's do that. Okay. Let's take it out. So we get AB equals to, have a look. In the first term I'm doing cos theta and cos phi is common, and I end up with, have a look, same thing is left over here, cos theta and cos phi. Okay, in the first term same thing is left because there's square, right? So same thing is left. Then comes a plus sign, and we have over here sin theta sin phi, sin theta and sin phi, because you've taken this part common, right? You've taken this side out, so you get plus sin theta and sin phi. And of course there are 4 more terms over here also, and there's one term over here. Total of 4 terms are there. Okay, great. One more time you're going to write AB. Cos theta cos phi remains as it is, and cos phi, and over here you're going to get what? Please check. This will become cos of theta minus phi. Cos of theta minus phi. This is going to be the second term, third term, and fourth term. Okay. What I did over here, I'll show you. So basically this part, have a look, this whole part becomes this. How come, sir? Cos A cos B, sin A sin B. It becomes cos of A minus B. Cos of A minus B. Is it clear? Okay. Great. So we have cos of theta minus phi. Now with that known, with this thing known, have a look. We can say that actually when you do the calculation, no, you'll find out that even this will have this term over here. Even this will have this term over here. This term will repeat in all the terms. In all the 4 terms, you'll have cos theta cos phi common always. Sorry, cos theta minus cos phi common. Take it outside. So you'll end up with cos of theta minus phi, and you'll have some terms over here. First term is cos theta cos phi, second term, third term, fourth term. You'll always have this thing. And they've also given you one thing. They've also given you one thing, and what is that? They've given that AB is equal to 0. It means basically cos of theta minus phi outside, and inside the bracket we have first term as cos theta, cos phi, other 0, this whatever it is, doesn't matter. This should be equal to 0. Now these values cannot be 0, okay, all the time, unless everything is 0. So, but this can be 0, sir. This can be 0 easily. What happens is, either this is 0 or this is 0. Which is easier to take over here, which is easier to relate over here. This part. Relate this cos of theta minus phi equal to 0. When that happens? When cos is at the odd multiples of pi by 2. When cos is at the odd multiples of pi by 2, it means that theta minus phi will be odd multiple of pi by 2. So, odd means 2n plus 1 times pi by 2. I want the value for theta, right? So, move this phi on this side. I get theta equals to phi plus. This phi is negative now, becomes plus phi. This is positive only, so 2n plus 1 times pi by 2. That's your result. N is an integer. N is a integer. Okay? Have a look. This is your answer. Option is C, right? Option is C. Please check. Option is C. Theta is equals to phi plus 2n plus 1 times pi by 2, and is an integer 0, 1, 2, like that. Got it? Done. This is clear. 8th one, fun question. If you are struggling in this, not a problem. As I said, struggling means you are learning it. Challenging means learning it. So please watch it a couple of times and try solving from your side also. Still have doubt, ask me in the comment section. Okay, moving on. 9th question. P is given, A is given, Q is given, asking for this condition. PTQ part 2005 is how much? Okay, they are asking us PTQ power 2005 P. Do one thing, write the value of Q. What is Q? PA PT. So write this PT as it is, and for Q will write PA PT power 2005, and P is of course outside. Now see the trick. I'll do the expansion of this. What does this means? This thing is multiplied 2005 times. I'll do that. Okay. PT, first bracket comes PA PT. Second time it again comes PA PT. Third time also it comes PA PT. Fourth time it also comes. 5 times comes, and the last is 2005 times it comes. PA PT. This is P. PA PT and P. Now check this out. What happens over here is simple calculation. PT and P is how much, sir? Simply I actually. I'm cancelling it. I don't have to write identity matrix, okay? Simply I. Here also it is going to be I, identity matrix. Again, this is also I, this also is I. Basically, I'm getting I, A, again I, A, again I, A, again, how many times? This is coming as 2005 times. Please check. Only A is left, right? I into A is how much, sir? Only A. Basically, I'm getting what? I'm getting this equals to A power 2005. A power 2005. Okay. So, for any power of A is given. What we do first thing? Find A square. Find A square. What is A? 1101. 1101. See this? This has no role to play in the question. This has no role to play in the question. Okay. Simply just to confuse you. 1 into, we're going to do row to column. So 1 into 1 will be 1. 1 into 0 is 0. So gone. 1 into 1 will be again 1. 1 into 1 is 1. So it becomes 2. Check this out. 1 into 1 is 1. And 1 into 1 is 1. So 1 plus 1 becomes 2. 0 into 1 is 0. And 1 into 0 is 0. So this becomes 0. 0 into 1 is 0. And 1 into 1 is 1. So it becomes 1. So when it is A square, it is becoming 2 over here. Please check. So if I am looking for A power 2005, this will become what? 1, 2005, 0 and 1. If you are not sure, do one thing. Find A cube also. How long will it take? Find A cube. Right here, A square into A. This is called as positive integral power of A. You write A square into A. So A square is this value, A1201, and multiply that to 1101. You will get the answer as, this will come out as 1301. Hence we can say A 2005 is what? 1 2005 01. Answer is done. Please check option is which one? Option is A, right? Option is A. Clear? Done? Easy? Had fun? Okay. Question number 10 now. Alright, similar again, we have to use some assumptions over here. We don't have to do the entire work. If you do that, it will take a lot of time and you can't solve it only. You have to use your brain very smartly. Okay. So before we do A, 10, we have to find what? A power 2. What are they asking? A power 10. What are you going to find? A power 2. Let's do that. A power 2. How do I do it? We have here cos alpha. We have here sin alpha. We have here minus sin alpha. And we have here cos alpha. Same thing, right? Cos alpha, sin alpha, minus sin alpha and cos alpha. Multiply carefully for the first time and from there you can make the assumption. Okay? Alright. And look at the options also. This will give you, more idea about your final answer. Here we have powers of 10. Here we have multiples of 10 in the angle. Powers of 10 for the value. Okay? And this will be multiples of 10. Okay? Got it? Chali. So let's start. Cos into cos, row to column. Cos into cos is cos square alpha. Sin into minus sin, how much is that? Minus sin square alpha. This is my first term. My first term. Cos square alpha minus sin square alpha. Okay. Next up, what we have? Column, again, so row to column. Second one we'll take cos alpha into sin alpha. How much is that? Cos alpha, sin alpha. This is for the cos and sin, and for this one, sin to cos, right? Again we get sin alpha, cos alpha. Okay? Right? Yes. Cos alpha into sin alpha is cos sin alpha. Okay? And we have sin into cos is sin cos alpha. First row is done. We're going to start again with second row, first column. Sin into cos becomes minus sin alpha, cos alpha. And this we have to do what? Cos into minus sin. Again becomes minus sin alpha, cos alpha. Please check. Cos and sin, over here minus sin and cos, and we have cos and minus sin, so same thing is coming. Again we're going to do this with the second column, minus sin into sin will become minus sin square alpha, and cos into cos will become plus cos square alpha. Now I'll rewrite this whole thing and in the easier format. Please check. We have cos square minus sin square. What do we have? Cos square minus sin square is how much? Which formula is this? Trigonometry, and it is cos to alpha. Cos to alpha. And for this one, cos alpha sin alpha, cos alpha sin alpha. It becomes 2 sin alpha cos alpha. How much is that? Sin 2 alpha. How come, sir? Think no. Sin alpha cos alpha sin alpha cos alpha. It becomes 2 sin alpha cos alpha. How much is that? Sin 2 alpha. Yes, same way. We have minus sin alpha cos alpha minus sin alpha cos alpha. What it becomes? Minus 2 sin alpha cos alpha. This becomes minus 2 sin alpha cos alpha. How much is that? Minus sin 2 alpha. And the last one, what is there? Cos square minus sin square. Same formula, cos 2 alpha. Please check. Cos square minus sin square. Here also cos square minus sin square. Becomes cos 2 alpha. Now we compare. If you have a square, this is 2. If you have a power 10, it will become what, dear? It will become cos 10 alpha. This will become sin 10 alpha. This will become minus sin 10 alpha. And this will become cos 10 alpha. Which option is right? Option B is correct. Cos 10, sin 10, minus sin 10, cos 10. Option B is correct as per me. You have a different answer, let me know. If you have a different answer, let me know, okay? I'll get to know what you're making mistake in. So if you have any other queries, getting different approach, give me that in the comment section. I want more interactions from all of you. Again, they'll start doing lives very soon, but before that, more interaction is better, right? Okay, so question number 10 is option B. Clear? Simple enough. Now last question of the day. Last question of the day will complete and will wind up our session. Have I taken too much of your time? Let me know that as well. Whatever changes you want me to make in the session, I want to have those comments. I want to know that feedback. Based upon that, I'll reevaluate whether it is required or not. If it is required, if it is possible at all to do from my side, I'll pakka do it. It's all for you, dear. Whatever we are doing on this channel is only for you guys. Okay? So you feel free to be a part of our content. Okay, everything. You are part of our whole journey. Okay? We are part of your journey. anything you have to ask us like a friend, ask like your family. We are your family only, okay? In whatever way is possible, at least academically, anything that we can do to help you out, please put that in the comment section. We'll certainly do it. That works out? Okay. Question number 11. A is given like this, B is given like this. Find A power 8, sir. Okay. Can we find a relation between A and B? Please check. Sir, yeah, sir, sign is same, but this is I and this is 1. Sir, this is I, this is 1, this is minus 1, this is minus I. It means something can be done, sir. If I take this iota common outside, I'll have here 1 minus 1, minus 1 and 1. Sir, okay, I got it. A is nothing but IB. A is nothing but IB. If I take I common from A, I'll end up with a number, a matrix which will become simply equal to B. So A equal to IB. Clear? Okay. Sir, you have A now. You have taught us. Whenever you get A, you're looking for A power, whatever it is. First find A square. A square means what, sir? I square, sir, and B square. Okay, it means we have to find B square also. But before that, I can write this as A square equals to minus, I square is what? 1. I square is minus 1. Complex number, okay? B square. So basically, I'm getting A square as minus B square. Now we have to find what? B square. Let's do that. Let's find B square. So difficult to do, sir. Why you are doing all of that, sir? Is it difficult actually? Of course not, sir. Let's do it. Let us complete this. B square becomes B into B, 1 minus 1, minus 1, 1, 1 minus 1, minus 1, 1. Row column, 1 into 1 is 1, minus 1 into minus 1 is again 1, so comes 2. How, sir? 1 into 1 is 1, minus 1 into minus 1, plus 1 becomes 1 plus 1 is 2. 1 into minus 1 is minus 1, minus 1 into 1 is minus 1 again, becomes minus 2. Here also minus 1 into 1 is minus 1, and 1 into minus 1 is minus 1 into minus 1 is minus 1. Second row, first column, again minus 2. Second row, second column, minus 1 into minus 1, plus 1. 1 into 1, again plus 1, so 2. Take 2 common. 2 is common, right? So I get over here 1 minus 1, minus 1, 1. Okay? Basically, I'm getting what? I'm getting B square equals to 2B. I'm getting B square equals to 2B. Getting B square equals to 2B. Isn't that makes our life easier? How, sir? I'll show you. B square equals to AB. I have A square equals to now minus 2B. How come, sir? Using this to this, that journey. B square becomes 2B, so A square becomes minus 2B. Again square it up. You get A power 4. A power 4. It becomes minus 2B square. How much is that? Minus 2 square is nothing but 4, and it becomes again B square becomes again 4 into, what is B square? 2B. How much is that? 8 square. 8B. How come, sir? I'll repeat. A square was minus 2B. A power 4 is minus 2B square. Minus 2 square is 4. B square is simply B square. B square is nothing but 2B. Use that over here. Again, we got 8B. Now I'm getting what? Now I'm getting so far A power 4 as 8B. A power 4 as 8B. What I want? I want A power 8. Again do square. A power 4 power 2 8B square. What I get? A power 4 into 2, we have to do product rule, right? It becomes 8. I told you, use the rules of exponents. 4 into 2 is 8, power rule, okay? And this becomes 8 square and B square. How much is 8 square? 64. What is B square? 2B. What is the answer? 128B. So your A power 8 is coming out as 128B. 128B. Option is option B only, right? Option is option B. Please check. Simple question. Okay. This is clear. Now after all of this, next comes your next part will be your KCET PYQs. So we'll do that in the next session. This is it for today's session. Okay. If you are really new to the channel, if you're not watched a lot of videos, do one thing. Subscribe to our channel right now. I'm telling you will be very, very happy with the content coming your way. We have more things planned for all of you, okay, to help you in every way possible in your preparation of KCET. And don't forget to keep the notification turned on. The notification bell should be always turned on, because it's not a other kind of content class. These are classes. If you miss one, it will be difficult to find and solve the questions in the next session. If you forget to watch the video of concept session, the other sessions will become difficult. You'll have a lot of backlogs. So make sure that you have watched all the sessions in that order, because you have a bigger goal in your life. What is the goal? To become the champions, the achievers from our content. Okay. This is the content. Again, these are students. We had a meet and greet. All of them came. They were very happy. We enjoyed. We had a great time with them. So we want also for all of you to study very hard and meet us next year. We'll organize an event. We'll have a fun time. Okay. You can give us a treat then. So this is it for today's session. We had fun, right? Any other feedback you have, anything you want to say to me, leave that in the comment section. You know that I replied to all your comments. Okay. I might be a little late sometime, but I do reply to all your queries. Okay. So I'll see you again very soon. Till then, take care. Bye-bye.